Welcome to the next video in my Android, Kotlin and Jetpack crash course. Today we're going to be looking at room for data persistence and something you can use for building an offline cache. So let's get started. So next up we're going to start building out a second fragment within our application so that I can show you navigation in action and all these kinds of things. But before we do that, I want to quickly show you how to use room. So you'll see at the moment I've got some errors in my project, and that's because I've partially built out this next fragment, but we can ignore that for now. Let's just focus on room. So room is basically like an ORM, an object relational mapping framework. It's similar to things like Hibernate and JPA and those kinds of things. It's not exactly the same, but let's have a look at it and we'll cover some of the differences when compared to these more commonly used or libraries and frameworks. Alright, so in order to include room, it's also part of Android Jetpack. I'm just defining the version. In this case I'm using version 2.10. That's inside my build.gradle, inside my app build.gradle. Then I just got two things to include at the bottom here. One is the implementation using that version, and then capped, which again is the Kotlin annotation processing tool, and the room compiler. Alright, now if you haven't already got it, also be sure that you have this line of code: apply plugin Kotlin capped. You will need that. Okay, then if we have a look at how we actually use room for persisting data. So as has been the case for a long time, SQLite is the database that you use on Android, and you can use it directly, like in the more kind of old school way, but room sort of abstracts away some of the complexities and makes things a bit simpler. So sorry, I went into the wrong class there. I meant to go into the database one. Okay, so where it kind of all starts is you generally create an abstract class called whatever database, and it extends room database. And there are a bunch of things you can specify in this annotation at the top here. And again, because this is a crash course, we won't go through too much of it, or too many of the different options. But basically, this version over here just helps with schema migrations. So version 1 is just like the first one I've written now, and then once I've actually run this on my Android device, if I make any changes to the schema, like I add a new table or a new column to that table, because remember this is all about persisting data into a SQLite database, I'd have to actually change the version when I change the schema, and then it will automatically do a migration. Now in this case I'm just using a destructive migration. Basically what's happening here is every time I change this version, it's going to completely recreate the database on my Android device. We'd look at doing actual migrations, like proper data migrations where you don't lose the data. There is a mechanism for that in room, but we won't look at it now. We'll look at it in a separate video. Again, this is just the crash course. And your entities are basically your classes that map to underlying tables. So in my case, I've got one table for water levels, and I've got an entity mapping to that, and we'll have a look at what that entity looks like. So this is what you specify in the database annotation at the top. Okay, then you will also create all your DAOs, your data access objects. Now those are different to repositories, and we'll go through the differences in more detail in more of the architectural videos. But just simply put, you can think of the DAOs, the DAOs, as the things that are going to interact directly with the database, where you're defining your actual queries. And we'll have a look at what that looks like in a moment. The repository is almost like a level higher than that. So if you're accessing, in this case, water levels through repositories, you don't actually, the calling class shouldn't care if it's coming from a database, like used for an offline cache, which is what we're doing here. We're going to be using SQLite database via room for an offline cache, basically. You shouldn't, or if it's making a network call and getting it fresh from, some remote external third-party service, the repository handles that internally. So it could be pulling data from a database, it could be pulling data from just that's been stored in memory, it could be pulling from third-party services. it kind of encapsulates all of that detail. Whereas the DAO, at least as far as this pattern within Android is concerned, is actually directly interacting with the database. So it would be used by the repository, but it's not the same thing as a repository. Okay, and yeah, this is basically just how you set it up. We don't really need to go through this in more detail. Then if we have a look at what an entity looks like, okay. So the first thing I've got here is this type converters annotation. Now, this is to handle types that aren't handled by room, sort of by default. So fairly annoyingly, dates aren't handled by room by default, and I want to have one of my columns. So all of these things that have column info above them are basically columns in the database table. So there's a date recorded column, and that's mapped to this attribute called date recorded, and it's of type date. Now because I've got that, it needs to know how to convert dates. So I've got to say that this entity uses the date converter, type converter, and I could specify multiple here. And then if we have a look at that date converter class, it's pretty simple. You create a method to date and from date, and you're basically just telling it how to convert from one state to another, right? So in this case, how to convert it from a date to a long, which is the milliseconds from the epoch kind of representation, and vice versa. And I just have type converter annotations on that. Okay, so the entity is quite simple. You also have to put entity annotation on it, similar to things like Hibernate. And I've specified my table name as water level table. And then, yeah, just a bunch of columns where I specify the names as part of the annotation. And you just declare your types like that. And you can see I've used the data class. So this is actually all inside a constructor. So typical Kotlin data class is perfect for this sort of thing. And I've just marked off which is the primary key and said auto generate the primary key set to true. Okay, and that's really as simple as it is for setting up the entities. If we then have a look at the DAO, so let's go in here. Okay, all right, sorry, I had some unused imports there that I just got rid of. Okay, so the DAO, this is basically where you put your queries. So first thing, you create an interface. You annotate it with the DAO annotation, and I've written a bunch of queries in here. For example, this is a typical insert query, right? And I've said, so I've marked it as an insert query with an annotation, and if there's a conflict based on the primary key, then it will replace the old record with the same primary key with the new one that you're trying to insert. And what's quite neat is you can also just make the argument of arg and pass through a bunch of these database water level objects. So it will actually do like a multiple insert, right? Technically, yeah, you can kind of see this as an upsert, depending on what conflict resolution strategy you use. Then I've also specified an update method, which you pass it a water level and it'll update the one with the corresponding ID. Delete, pretty self-explanatory. It deletes the one you pass through. Again, just all annotation based. And then you can start specifying custom queries. So for example, he has one for deleting everything, and he has queries for getting all the water levels, a typical select query. He has an example of, this is an example of one that returns some values. And you can see I can actually return a LiveData. I covered what LiveData does in one of the other parts. But these database water level objects that I get from Room, you can actually wrap it in a LiveData object right there and then as these things are updated, wherever this LiveData object is being referenced will just automatically update. So it's quite neat. And similarly over here, this returns a single LiveData object because I want just a single water level. And this is an example of how you can pass through a parameter. So in this case, it's called water level ID, and I'm using that parameter in the query over there. So those are some example queries. Okay, and remember, if the thing could return a null value, you must just let it know by using the standard Kotlin question mark operator. Alright, so that's pretty much it. I mean, you create your database, you create your DAO, and you create your entity or entities, and then you basically just yeah, you just use that stuff. So if we have a look at how we use our DAO, if we search for usages, we'll have a look inside the water level repository. So now what I've added is, so if we just look here again, where I was retrieving my water levels from a remote third-party service, what I then do is I call this method persist water level, which does some stuff where it like looks up the most recent water level under certain conditions, it updates it or inserts it or whatnot. But you can see the way I access it is database.waterlevel.dao and then dot and then the name of the query. And yeah, that's it basically. I could have made this one a LiveData as well. I didn't really need it to be a LiveData, but so you can see that this get most recent water level. It's just a standard database water level. As I say, you can make it a LiveData or not. Sometimes I find it's better to have one and the other in other cases, but yeah. Okay, so that's how you access it from the repository. So now we're going to take a look at how to actually test the stuff we've done with Room so far and see if our database is set up correctly. We want to do an automated test for it. So the first thing to note is just the dependencies we need to include. They should be included for you already when you just set the project up. So the ones I've got highlighted on screen now. And then just one quick potential pitfall, something I ran into when I set this project up. And I think this might have been something that I just didn't select correctly, but it was originally set up with this line test instrumentation runner with the non-androidx value. It was android.support.test.runner.androidj-unit-runner. And then when I actually try to run my room database test, it would say that no tests were found and the process would crash and you'd get an error. So just make sure that you actually have androidx.test.runner.androidj-unit-runner in here. So that's important. And then before we look at the Drizzle-Arm database test specifically, I just want to make a note on package structure. So you'll see that there's a source Android test as well as a source test directory or directories. Now the unit tests are the ones that are put inside of tests. So there's an example unit test that's generated for you when you create the project. Very simple, 1 2 + 2 = 4. And I'll do a separate video giving more detail around the definitions of like unit tests, integration tests and stuff, more broadly speaking, even outside of the Android scope. But for now, just know that anything that interacts with something external or a different internal component, even just like a database, that's not a unit test, that's an integration test or potentially an acceptance test, but acceptance tests are usually like a specialized form of integration test. So this unit test is what would go, well, these unit tests would go inside the test directory. Inside of Android test, you'd have things that, for example, interact with the database. So technically, this is an integration test. And this is where I've deleted the example one that comes with the project, and I've put my own one called Drizzle-Arm database test. So you start off with run with Android J Unit 4, that annotation, you create your test class, and I've got two members in here, one for the DAO and one for the DB. Then you would create a method that runs before every test. That's why it's got the before annotation, and you create your DB and your DAO that you're going to be using to test inside of that. You'd also then have a method that runs after every test method, and you close the DB there. So that before and after would run before and after every method in every test in this test class. So I've created two test methods. The first is insert and get single water level, and the second is this one, insert and get multiple water levels. So the first one is just creating a single water level and inserting it, and then retrieving it and checking that the number of results is as expected, 1. And you'll see the method I'm using to test it is not one that uses LiveData. You would then that's like an observable and complicates the test a little bit, but yeah, like there's a timing issue. So I've just created like effectively like a static version of it, where it's just a static result, a non-observable kind of result is returned. Okay, and then the same thing for the second method. I just inserted 2 water levels using the var args insert method, so you can pass through multiple things here. Okay, so it's important to note that these do not have a shared fixture, which is what you want. You don't want a shared fixture. So what I mean by that is when you add water level 1 here, at the end of this test method, the database is effectively cleared so that when you add water level over here and a water level over here, if you run the two tests sequentially, it's not adding 3 water levels in total, one from the first method, one from the second, and then another from the second. It's actually adding 1 in the first method, and then you doing that test, it's then effectively removing it because it's recreating the database effectively, and then you add 2 fresh ones here. So to run this, you can just right click on the class itself, or you could actually just right click on the method name if you wanted to just run for that method, but I'm going to run for this whole test class. So it's going to run 2 methods. I'm just going to pause it while it runs. Okay, so now it's finished running, and you can see it says that 2 tests passed. Okay, now note that I do have my phone plugged in. For a unit test, you wouldn't need a device, but for an integration test, you need your device plugged in, or you need to specify a virtual device that you want to run this on, because it actually needs to physically create the database and that sort of thing. Okay, and then just to show you what it looks like if it fails, if I said this one expects 3 instead of 2, which is obviously going to fail because I've only inserted 2. When I run that, let's pause it again. Okay, you can see I run it and it said there's an insertion error, expected 3, but was 2. And just one thing worth noting, this applies to automated tests in general, make sure you get your expected and your actual results the right way around in your assertions. Because this would still work if I switched around the 3 and, well, what's supposed to be a 2, if we wanted to pass. If I switched the 2 and the water levels.size parameters around, it would still work, because it's still checking is 2 equal to 2 if the size is 2. But the problem is when it doesn't work, like when it fails, you know, if there's like a regression issue or something introduced, it becomes difficult to understand what's going on, because it'll say expected was you know, X but was Y, and those are actually switched around, so you think that your actual result is what you're getting, but it's actually what you hard coded as what was expected, so it becomes confusing. So it's just another little pitfall to watch out for. Yeah, and that's it. It's as simple as that. Thanks very much for watching this video. I hope you learned something, I hope you found it interesting, and I hope you continue to watch the upcoming episodes of my crash course. And if you're enjoying this, please subscribe to my channel.